Does the initial velocity affect the flight time when launching a projectile horizontally? Let's ask an electrical engineer.
Yes, it does.
Well, I think you need to go back in time and learn the basics of physics.
Oh, sorry, I know more about electrons.
The goal of this lab is to verify if the initial velocity is truly independent from the flying time when launching a projectile horizontally. In class, we've learned that the flying time is independent from the horizontal speed. We also know that a projectile's horizontal component is constant throughout the flight time if we're neglecting air resistance. As for the vertical component of a projectile's velocity, it can be compared to the motion of a falling object. Therefore, it's fair to say that the horizontal component of motion is not linked to the projectile's falling distance. Based on this, we can confirm that whatever the horizontal velocity is, the object will have the same flying time if released at the same height and angle.
For the material used in this lab, we had a projectile launcher, a clamp, a smart gate laser, a time of launch pad, a metal ball which was the projectile, and a computer with the capstone software. During the lab, the projectile launcher was clamped on a desk with an angle of 0 degrees and a height of 0.98 meters. 3 tries were made for each speed that the projectile launcher offered. So a total of 9 tries were made, and each projectile landed on the time of launch pad according to the distance of travel. The time of launch pad recorded the time of flight, and there was the smart gate laser which was attached to the projectile launcher that recorded the initial speed.
For an initial velocity of 3.04 meters second, we obtained a 0.45 second flight time. And as we can see, the flight time stays the same even if the velocity increases, so 4.19 meters second and 5.56 meters second. We also calculated the flight time when just dropping the marbles with an initial velocity of 0 meters second, and it gave us the same exact flight time.
So as indicated by our results, 0.45 seconds was the time of flight for 3 different initial velocities that each had a different distance traveled for the projectile that was launched. Also, the theoretical time it would take for a projectile to fall from that same height of 0.98 meters is also 0.45 seconds. Therefore, we can assume and conclude that the horizontal displacement does not have any effect on the time of flight, because the time of flight is only influenced by the vertical component, which is the same for all projectiles, and that vertical component or vertical force is the force of gravity, which is 9.81 meters per second squared for all things on Earth. Although our results were all 0.45 seconds for the time of flight, there still is a possibility of some sources of error that could have influenced our results. So first of all, there is the calibration of the time of launch pad, which could have completely indicated wrong results, if not well calibrated. And second of all, there is the angle of release that was indicated only by a little string that wasn't really precise, and that could easily have led to false results.
To conclude, the same flying time of 0.45 seconds was obtained even if the initial velocities were different. Doing this experiment was a way for us to confirm our understanding of the theory since we got to see it in action. Apart from verifying our hypothesis, we learned how to use capstone to record our data.